Okay, get set up and we'll wait a little bit in case anybody's running late. It's going good, everything's good, perfect. Okay, so while we're waiting, let's just talk about some administrative stuff. So assignment number 1's graded. Did I grade assignment number 2?
No.
Okay. Oh, that one's due today. Oh, that's right. Okay, so the due dates lined up kind of weird. I should have actually probably just made this one due before, but I didn't. I think everyone's already finished assignment number 2, right?
Yeah.
I'll just probably just grade that when I get back to my office. So this, what I usually wait for is this due date to pass. I like to sit down and grade everything at once so I stay consistent with the grading and I make little notes on common mistakes and that sort of thing. So that's why I like to grade them all at once. And then I guess I wasn't paying enough attention because I made 2 and 3 due today. Really, two could have been due last week, honestly. But did anybody have any questions about this assignment? Okay. And then I know we don't have a huge number of people in here today, but how many people finished assignment number 3 and already submitted it? Or finished and you're going to submit soon? Okay. Okay, we don't need to talk about that then. Usually I do a lot of review and overlap, but because A, this is recorded, and B, it's this hybrid format where we don't have as much time for that sort of thing, I try to make the examples unique. So I'm not going to talk about anything related to assignment number 3. If you have any questions, go back to the previous lecture. And we did an example very, very, very similar where we were buying gravel or sand or whatever. This is some variant of that. Okay, so I'm not going to assign a new assignment this week because we're going to talk about collections of things, so like lists, loops, so while loops and for loops, and I think we're going to, if we have time, start functions, and then next class we'll get into functions. So your next assignment is going to be based off of loops, lists, and functions, which it would have really not been fair for me to assign it today because we may not get through everything, so I'll assign it next week. Okay, so let's get right into examples. Are there any questions on anything? Okay, let's get right into it. Am I actually streaming? Yep. No dropped frames. Perfect. Okay. So let's first talk about loops. And I think everyone remembers how a loop works from most likely COP2030, but maybe other programming classes. Let's do the while loop first because it's not as often used, but it's conceptually very easy. Is that it's going to be while some condition is true. So we could just write the full word true, but let's do this. So I'm going to say I is equal to 0. while I is less than, let's say, 5, and then we have the colon, we'll say print I, and then I is going to equal to the old value of I plus 1. Yes?
I plus plus?
No, and we'll go through that whole process. We can do I plus equals, but we can't do plus plus. Unless that changed. We'll try it, but I don't think we can. I'm pretty sure we can't. Okay, so we run this. So what happens is that we test this thing right here to see if it's true. Probably go a little bit larger. Is that a good font size for everyone?
Yeah.
Okay. So I is equal to 0. We set up some initial condition, and then we say, while I is less than 5, and then remember when we're doing these code blocks, normally in other languages we would have done like curly braces. Here we just do a colon. And then the next line we indent. So we see this line right here. So we indent. And we're just going to print I just to see the value of I. And then we're going to say I is equal to the old value of I plus 1. Remember the way this is evaluated is that it looks at the stuff on the right-hand side of the equal sign. So it starts off at 0 and it does 0 plus 1, which is 1, and then it stores it over here. Is 1 less than 5? Yes. Prints I, keeps on going. 1 plus 1 is 2. Stores it over here. Is 2 less than 5? 2 plus 1 is 3. 3 is less than 5. It keeps on going on all the way until we do 4 plus 1 is equal to 5. Is 5 less than 5? No, it's less than or equal to, but it's not less than. So this is going to be false, and then it's going to be finished. So we can write just maybe print. Always be careful of this indentation. It's a very subtle thing that I see people making mistakes well into the semester. Remember that it's a colon, and then we indent to let us know that we're working with a code block. So that's a while loop. Pretty straightforward. I don't want to spend too much time on it. It's just like a while loop in other languages. Any questions on how the while loops work in Python? I do want to spend some time talking about for loops because those are a little bit less straightforward. So let's open up another REPL here. So in other languages, I'm going to write some code. It's not valid Python code. I'm just going to erase it right away, so don't type it. In say C, we would have something like this. We'd have a for loop, and then we write for int I is equal to 0, I is less than 5, I plus plus. We don't have this version of the for loop in Python. Okay, so just completely wipe this from your not completely wipe it from your memory, but for Python purposes anyway, because we're not going to use anything like this. What do we do instead? It's something called a for each loop, where what we do is for each value of something, we loop through it. So let's do an example. So we use the keyword for. The value that we're going to have, in this case I, in some list or enumeration, or it's more generically called a generator. So let's do this. There's a function, so keep what you have typed, but I'm just going to let you know. So there's a function called range, and what that does is that gives me the values 0, 1, 2, 3, 4. I might need to actually print. Let me do print range. Sorry, it's running a little slow. Here we go. Okay. So what this function does is it gives me the values 0, 1, 2, 3, and 4 eventually. There we go. And hold on. There's a lot of magic that happens in the background. Sometimes we have to write complicated code to make things. Okay, there we go. So this range function gives me 0, 1, 2, 3, and 4. So it gives you the values from 0 to 5, not including 5. So what we can do is we can say, okay, for I in, so I is the variable we're calling it. We could have just as easily called it number, but I is very common. In is an actual keyword, in, notice that it's blue. And then this range function is going to return 0, 1, 2, 3, and 4. And what happens is that each time we loop through, this value I gets that value. So let's just do a print so you can see what's happening. So the first time through, range gave us 0, and so it took on the value 0, so I is equal to 0. The next time through, it said, okay, the next thing is going to be 1, so it assigned 1 here, and so on. Now, in practice, we don't actually tend to use this very often. So let's do this. Let's just for a second, let's comment this out. Now, last week we talked about lists, correct? Everyone remembers a list? Very, very similar to an array. And let's do this. Let's create a list of names, and what we can do is we can define it at, we don't have to add to them, we can just define it all at once. And so Alice, Bob, Charles. Okay, so in this list we have 3 names. Remember, we have regular variables, sometimes called scalar variables, and those just hold one value. Collections, in this case a list, hold many values, because a lot of times what you need to do is you need to group them together logically. In this case, I've got all these names together, and it makes it so that I can operate on them as a group rather than individually. Now, if I wanted to print an individual name, just like with C-based languages with arrays, I could do names, and then, so it's 0 indexed. So what's this going to print? Names?
Bob.
Bob, correct, because Alice is 0, Bob is 1, Charles is 2. So let's just print it just to make sure that language still works like I think it does. Perfect. And if we try to do something out of range, we'll actually get an exception. Yeah, out of range. So we'll just leave with Bob. Trying a little slow today. Try it again. Yours is 2. So knowing this, so let's just comment out the print. We don't really need that anymore. I don't like to delete code when in class. In practice, you delete things, but in class, I like to keep it around so you know everything's additive for us. So if this gives us 0, 1, 2, 3, 4, what we could do instead is we could say print names and then I. Because remember, I is going to, each time through, first time through it's going to be 0, next time through it's going to be 1, and so on. So this kind of works, but what happens when it runs is that we're going to get a exception when it finally runs. Try getting another container here. Okay, that one's working faster. So it went name 0, which is Alice, name 1, which was Bob, name 2, which is Charles, but name 3 doesn't exist. So what we could do is we could, okay, if we hard code this to 3, this will give us 0, 1, 2. But there's actually a function that returns how many elements are in that list. So we could print, it's called len for length. So it's saying, oh, okay, there are 3 items in that list. So what we can do is rather than hard coding the number 3, we can do the range of length of names. So this function is gonna return 3, and it's gonna say, okay, the range of 3. This is kind of like the C-based way of doing things. We actually don't use this technique that often. So we got for I in. Remember, this range function is going to give us back the numbers 0, 1, and 2, right? Because we had the length of names, which is 3. So range of 3 is going to be 0, 1, 2. And then we use this square bracket notation to get each individual element of the list. But like I said, we don't actually tend to use that very often. So let's comment this out. What we can do instead, which is much more common in Python, is that we can say for name in names print name. So what that does is it says, okay, names is a list. I know how to go through that list one name at a time. So the first time through it gives us Alice. Second time through it gives us Bob. The third time through Charles. To me, this is a lot cleaner. I would imagine most people agree, this versus this version. But you have to kind of get your mindset out of the C way of doing for loops. This would be the C version where, okay, we get some numeric offset and then we treat this like an array. But this is much more common. Now, we can have the best of both worlds because there are times that you need that value. So sometimes what we'll actually do is for I, comma, name, and there's a function called enumerate names. And this will give us both. It'll give us I and the individual name. One of the most common reasons I do this is because, I mean, there's a million uses for it, but let's say, for example, I have to process 10 million data records, and it's going to take a few hours. What I'll often do is just to kind of create a cheap and easy progress bar is that each time through I'll just print I, or every 50th time through I'll print I. And then so it makes it so that I can still access name, but I also get I. And I don't have to do this whole complicated range length of this thing. I just use this one function called enumerate. The most common is going to be this. Most of the time you're going to be dealing with this, but this is also used when you want both the offset and the thing, the item itself. What's that?
The internet just died.
Oh, that's not good. Did everybody's?
Died.
Were you on the Wi-Fi? I've noticed that are you on the the one called IRC? See, I'm on a different one. Are you on the guest one?
Mm-hmm.
Yeah.
Oh, very good.
Did it come back up finally? Okay. I've noticed that it's been going in and out lately. I'll mention it after class. See if somebody can give me a reason. But you're good now?
Yeah.
Okay. Okay, so that's 3 different ways to loop through this right here. Let's combine a while loop and for, and let's try to do something useful. Okay, so anybody need to copy this? I can uncomment out so you can see it a little bit better maybe. Is everyone good? So these are 3 different ways to do the same thing. Okay, so let's start another example here. Last class we did the example where we found the average of a bunch of, let's say, grades or GPAs or whatever. Really just more generically the average of numbers. What if we wanted to create an interactive version? So rather than hard coding the numbers where I had to change the code each time, I could run the program and then the user would directly provide me those numbers. So what I could do is I could use a while loop, and I'm going to use it in kind of a strange way. This is called an infinite loop. Have we talked about infinite loops in here?
You mentioned it last time.
Okay, so an infinite loop runs forever. Just the name kind of describes it pretty well. It just runs infinitely. So you might think that's a useless thing, right? Well, there's some uses for it. In microcontrollers where you want something to run forever, it's very common to do there. But what we can actually do with an infinite loop is we can manually decide when to break out of that loop. Okay, so let's do this. So we've got this while true, and then we'll do this. So we'll tell the user, I'm trying to think of a good name. Just very generically, we'll call it val for value right now. We might want to change this. Let's do this. So I'm trying to think how it's going to format. I think it'll format best like this. So we'll say enter number or Q to quit. And then we'll say val is equal to, and they'll enter it here. We might have been able to do it as one line. This is a little bit strange, but I've already typed it, so we'll deal with the mistake. And then what we can do is we can say, so at this point, I know this is going back to early stuff, but at this point, what data type is val? Is it a number or a string?
String.
It's a string. So what that means is that if they typed in Q, I can test for that because it's not a number. So I can say if val is equal to Q, and then I can use a special keyword here called break. And what this does is it breaks out of this while loop. And be very careful how you type this, because if you type it wrong and the infinite loop keeps on going forever, I think it will crash the tab. So be very careful. Pretty sure I typed it correct, but we will find out in a second. So I can enter in some numbers, and then right when I hit Q to quit, it breaks out and the program's finished. So why might that be useful? Okay, let's keep on going here. So let's, at the top of our code, create an empty list of numbers. So we'll say numbers. And if we just do the square brackets like this means that it's an empty list. We've created a list, but there's nothing inside of it. Okay. So at this point in the code, at line number 8, because of the way this break works, is it breaks out of the loop. So at line number 8, we know that we've already handled that the value is q. So at line number 8, essentially, we know that it's a number, unless they entered in an invalid input, which we could process. But here we know it's a number. So what we can do is say, okay, q was a letter, but we've already processed that, or a string, I should say. Let's go ahead and say that, and let's say number is equal to the float version of the value that we took in from the user. And just to check, I like to put these little checks along the way and test things. Let's actually print the number and see if it correctly turned it into a number. So if I enter in 5, it should give me back 5. Perfect. And 5.0 because it's a float. 5.3. Perfect. And then this Q to quit still works. So at line number 9, we can be pretty confident that it's correctly turning that string into a float. So what we could do is then take that number and append it to our numbers list. And there's a method here called append. And what we do is we say, okay, to that numbers list, go ahead and append this number, the float version. And then outside of the while loop, let's go ahead and just put a print of numbers. Notice that this is left indented, so outdented, I guess would be the term. So all this code right here is part of the while loop, but line number 11 I sent in the left direction. And the idea is that I just want to make sure that it's correctly grabbing all those numbers. So 4.3, 2, 5, and then now I hit Q to quit, and at the end, it should give me those 3 values, which 4.3, 1.2, and 5.0. Perfect. So now that we've got all these collected inside of a list, what we can do is a plain old simple for loop like we learned in the last example for I in numbers, and each time through it's going to give us the number. And maybe let's be a little bit, it doesn't always have to be I, so we could say for number in numbers, remember we create these variable names. The goal is to add all this up if we're going to find the average. So where do we put that number? We can say total is initially equal to 0.0. And then we can say that the total is, so I could say that the total is equal to total plus number, but what do you remember from COP2030 that we could do instead? We can do plus equals. And that increments the total by that number. So this and this are the same thing. But it's much more common to see the version on line 13. And then what we can do at the end is we can print the total to make sure that it's adding up correctly. So we do 4, 5, 6, and then Q to quit. So it should be 15. 15, yeah, that's correct. And then we had to do the one final thing to find the actual average. I didn't really care about the total. My goal was to find the average. So I could say that the average is equal to the total divided by, well, I could hard code some number here, but what function did we learn about to actually get number of elements in that list?
Oh,
Yeah, len, short for length, and that function will actually return how many numbers there are. So in that case, there were 3, but this is dynamic, so this is perfect because we don't have to hard code anything. Notice that I don't have any hard coded numbers as far as like the size of the list, the number of times to loop through it, any of that. Everything is dynamic.
very flexible.
What's that?
Makes it very flexible.
Exactly, yeah. So you never have to go back and change the original source code. Everything's done at runtime. And so let's test this one more time. Oh, probably want a print statement at the end just to actually print the average. And let's not forget about our F strings. So 15 divided by 3 is 5, works out. Any questions on this? Okay. So let's keep on moving on here. There's another data type called a tuple. It's very similar to a list, but we use it kind of a little bit kind of a different way here. So with a tuple, it's going to be read-only. And let's just start typing. It's probably easier to explain once you see. It's very similar to a list, but use it in a slightly different manner. So imagine if I had GPS coordinates, and I had GPS coordinate lat, and obviously this is not what they look like. They're very, very long decimal numbers. So this is one way to represent these GPS coordinates. But a lot of times we want to group things together. We've already seen this. With latitude and longitude, this might be better represented as something called like a coordinate or GPS or something. We'll just call it GPS. So what I can do with this thing so what I could do with a list is I could say GPS is equal to the coordinate 1, 2. And then anytime I wanted to get latitude, I would just know that GPS 0 is going to be the latitude, and GPS 1 is going to be the longitude. Well, we don't actually tend to use lists for this. There's something that's a little bit lighter weight and has some restrictions, something called a tuple. Now, the only difference in defining it or creating it is we would do the same code, except we would say GPS is equal, in parentheses, 1, 2. And we would access it the same way. I guess we could have added some print statements, but you know what it would print. Here it would print 1, 2, 1, 2, so. But let's say, for example, here we wanted to change the GPS 0. All of a sudden now that value is 4. So this will run. If we tried to do the same thing here, we get an exception. So just knowing that, what do you think the main difference between a list and a tuple are?
The list can be changed, tuples really can't.
Exactly. Tuples are read-only, which is kind of nice and convenient. And because they're read-only, it makes it so we can use it in other, it's what's called immutable, meaning that it can't be changed. Once it's been assigned a value, a tuple can't change. It makes it so that we can use it in other data structures that require immutability, like something called a dictionary, which we'll get into a little bit later. But it's very, very convenient as a very lightweight data structure that we don't want to be changed. And so we use these all the time for these very simple data structures where we don't want to have separate variables, latitude and longitude. And so I'm going to comment this out. And what you'll very often actually see is a list of tuples. So I could have a list called points, and that's going to be a list of, let's say, 3 tuples. And this would say print all the longitudes, right? Because we just made up our own little system where the 0th slice is the latitude, the first one is longitude. Same thing here. So you see 5, 3, 2. You don't tend to loop over these tuples the way we do lists. I think you technically can, but it's very rare in code I see people try to treat it like that. Most of the time what you're usually doing is treating it as like a little, almost like an anonymous read-only data structure. Like if I've got a bunch of points and I know that they're not going to need to change values, they're just set, then that's a perfect example. So those are called tuples. They actually have something interesting in the new versions of Python. They have something called a named tuple. I don't think I'll go over it. It's maybe a little bit outside the scope of a beginner class, but it's kind of nice because you know how we created our own system where we said, okay, 0 is latitude, 1 is longitude. You can actually name them. So rather than having to go 0, 1, you could actually access it lat and lon. So yeah, it's pretty convenient. Now, to be perfectly honest, I don't actually. It's kind of a new feature, and it takes me a while to start using. I'm just so in the habit of using these tuples for various things. I just use the plain tuple. But if anybody's interested, they're called named tuples.
So, all tuples themselves are like unmutable, right? They can't change.
Correct.
You can still like pull a value from them and use that to like another number for arithmetic and stuff like that.
Correct. Yeah. So you can read it as much as you want. And you can do arithmetic and all that. The only thing I couldn't do, and you can even make a copy and then change that copy. I just can't do this. So I don't want to get too advanced. Maybe if this confuses you, you can leave it out of your example. But if we wanted to make a copy, we could actually do that. So we could say, so I could say GPS underscore LST for the list version is equal to, and I can use this function to make it from a tuple to back to a plain list for GPS, just for that GPS coordinate. So here GPS was a tuple, but I can turn it back into a list, and then I can say and this will actually work because it's no longer a tuple. But had I not used that list, if I had just done this and left it a tuple, it would complain. It's because I've turned it back into a list. But this is a little advanced for what we're doing in here. So if you understood what that is, you can leave that as an example, but I don't think we'll probably need that. So we're doing good on time. Let's do two more things. Let's talk about dictionaries. Now, dictionaries are probably very different than anything you've seen in COP2030. I don't think they really have an equivalent in that class. So let's go through and define a dictionary. Let's say, for example, we've got just a simple phone book. And the way we create an empty dictionary is that we have these curly braces. Dictionaries are nice because rather than always having to use numbers, we can use strings as the key. So for example, I could say phone book, and then the string Bob is equal to 555 1234. And then now, rather than having to use a numeric offset or having to loop through, I can directly look up keys. So I can say print phone book Bob. It'll retrieve the value at Bob, which is 555 1234. So we get to look up rather than by number, we get to use some sort of more useful key, because for the most part those numeric offsets really don't make any sense to us. But in this case, we've got some sort of key. When to use each will usually be pretty natural. Like, for example, if I've got a bunch of, if I've got to process the whole school of GPAs and I don't really care about which GPA belongs to which student, I just need a final answer, that'd be a good example of a list. Because it doesn't really matter which GPA belongs to which student, I just am calculating a final result. But in the case of like a phone book where I might need to look up later, or in the case of like a student record system where I actually need to know which GPA belongs to which student, in that case it might be more useful as a dictionary. So it's usually pretty natural which you're going to use. And so say, for example, so we can comment this out, let's make a very simple phone book with 3 people. It'll be Alice, Bob, and Charlie. Keep it simple. So Alice will be 1111, Bob will be 2222, and Charles will be 3333. So as we already saw, I can look those up individually, but let's make an interactive program that says, okay, enter the name of the person that you'd like to look up. Then what I can do is whatever name they gave me, I can look it up just by that variable name. So I don't have to hard code these strings. If they gave me a name that's in the phone book, I can just print that name. Which we wouldn't have really been able to do with a list. With a list, I would have probably had to loop through everything, maybe stored it as a tuple, where the tuple was the name, comma, phone number, and name was like contact 0, the number would be contact 1, and I'd have to loop through the whole thing, checking along the way. Dictionaries are nice because we can just go directly to the value. Is that we've got some sort of logical key. By the way, we call these key value pairs. We've got some lookup key, which is the name, and then we can immediately go right to that value, which is the phone number, just by typing in phone book, square brackets, and then that name. Now what happens, a little bit of error handling, what happens if we enter in a name that doesn't exist? We get an exception. So one of the things that we can do as a quick check, we can actually see if that key exists in that dictionary. And the way we can do that is we say, if name in phone book, and that'll actually check to see if the name they entered in, if it's one of these keys, Alice, Bob, or Charles. Else name not found. So Alice is still in there. Now we get a nice error message. Any questions on dictionaries? Yeah.
Would the capitalization of anything matter?
Yes. Actually, let's go through that. We're doing good on time. Am I leaving anybody behind? Does anybody feel uncomfortable at all with this example? I don't want to get into super advanced stuff if anybody's feeling behind, but so the question was, is this case sensitive? Does capitalization matter? Yes, it does, because, for example, if I entered in Bob all capitalized, name not found, because as far as it's concerned, those are two different strings. So a very common technique is that what we can do is there's a function called, it's either lower or lowercase. I'll have to look it up. Yeah, it's just lower. Sorry, in other languages, it's the full word lowercase. So what we can do is we can say, okay, once we get the name, and this is a very common input validation, not really validation, cleanup technique, is that no matter what they entered in the name as uppercase, lowercase, or some combination in between, we can say, okay, take that name and then give me the lowercase version of that name. And then whatever they entered in, if they entered in all capital letters, it'll convert this to all lowercase. And then all we have to do is make sure that when we are creating our phone book, to make sure everything is entered in. So what I often see people do in programming assignments, especially if it's like a yes or no question, like a menu-based program, they'll check for capital Y, lowercase y, capital full word yes, lowercase. What we can actually do is just, a much easier technique is just to force everything to lowercase or uppercase. I personally like lowercase better. And then it's always going to match the version in the phone book. And so now if we run it, I can enter in any variation of it. Oops, try again. So I can do all lowercase still. Now I can also do the capitalized version because it forced it to lowercase. Okay. A lot of these things I'm just sort of introducing. We're going to do more sophisticated examples as we go along, but this is just a basic introduction to dictionaries. And then I have one more example to do today, and then I guess I have a feeling it's not going to take the full 25 minutes. Then I can answer questions about the assignments if anybody's working on it. Okay, is everyone good with this? Any questions on anything we've done up to this point? Does everyone feel comfortable with the material? Okay. Now, to be perfectly honest, when I teach the intro class COP2000, there's kind of a part of me that it's a tough class to teach because I know we can only barely scratch the surface, and it's tough to write real world programs just after having that class. You get fundamentals, you get the basics. What's nice about this class is because A, I can you've already had the fundamentals, but B, Python is such a compact, concise language, and it's what they call expressive with not a lot of code. At the end of this class, you can write real world things. So realistically, with dictionaries, lists, tuples, all these basic things, loops, you can write some pretty interesting programs. I've seen people in the past just with this, be able to write like text-based adventure games and that sort of thing. And so you can actually do a lot just with what you've learned in this point in the course. So let's do one more thing here. Let's talk about functions. Now, you probably already remember functions from COP2000, but I'll give you my quick version in case anybody else had another instructor. The idea of functions is that I want to be able to write reusable code. Now, that's the main reason, but that's not the only reason. It's what we call abstraction. It's where I can take something kind of complicated and I can abstract it away. So let's say, for example, the example I like to give is, imagine if you went out and you bought a drone, like one of those quadcopter drones, and they might have some API where you can pass it a GPS coordinate, and then it'll fly to whatever GPS coordinate you give it. And it might just have one single very simple function that just says, go to GPS. That one function might have 1,000 lines of code. You actually don't write functions that large, but you get the idea. It would have lots and lots of code doing a bunch of things. It would have to check the battery level to see if it can actually go there. It would have to check to see if it's an actual valid GPS coordinate. It would have to check to see maybe if there's any obstacles along the way. There's probably some sort of stabilization algorithm. There is maybe algorithms to make sure that it doesn't go through and crash into trees or other objects. There's going to be a lot with that one simple function. And so we've encapsulated a lot of the complexity to where, hey, I'm just going to give you a GPS coordinate. It's got to make some delivery. Say, for example, it's like one of those drones that Amazon's working with where it drops off your package. And there's just this one function. I call it, I'm not a drone expert, but I know how to call functions. So I can call that function, and then a lot of things happen. That's kind of the base case for functions, is that we can encapsulate things. A lot of times we're encapsulating complexity. Other times I'm just doing some relatively simple piece of code a bunch of times. Let's say, for example, I've written a program to print a menu, like it's a menu with 10 choices. That 10 choice menu is taking up a bunch of lines of code. I can push that off into a function. And let's say, for example, we've got that menu in 5 different spots in my program. Depending on where you are in the program, it's like, say, a help menu or something like that. Let's say I misspelled something in that help menu. If I don't have that in a function, I'm going to have to change that in 5 different spots. Anytime you find yourself changing code in a bunch of different places, it should be a giant red flag that you're probably doing something wrong. Because in reality, you're usually not the only programmer. You're a team of programmers, and that other person who got assigned the task is going to have to go through and find all the different places that you use that code. But with a function, you only have to change it in one spot. So we've got 2 use cases so far. We've got hiding complexity, where I can take something very complex that I might not even be necessarily qualified to do, like writing a shortest path algorithm for a drone or something like that. The next case is if we have duplicate code in different places, it forces all the code into one spot. And then finally, it's just nice to be able to read functions. It makes it so that you can read your program more like English than a program. So if I've got this very long menu, and let's say, for example, that menu is only in one spot. If I abstract that all the way to just one function called print menu, I've turned maybe 20 lines of code, highly formatted code with tabs and a nice border and all that stuff around it. I've just hidden that away in a function called print menu, and now I only have to look at one line of code and say, okay, here's where I'm printing the menu. Does that make sense? So we've already used functions, but let's learn how to actually write our own function. We're going to write the simplest function in the world just so you understand the structure of how to write a function. Okay, so to write a function, we use this keyword called def, which I'm assuming is short for define. I've never even actually looked it up. And we're going to call it add to numbers. It's going to be the world's most useless function, but it's more about the structure. And the two numbers we're going to have are going to be A and B. And then we're going to say that the result is equal to A plus B, and then we're going to return result. The way I like to think about a function is that it's a box. And it's some magical box where you don't really care what happens on the inside. If you're the one writing the function, you have to know what happens on the inside. But for the person using the function, they just need to put things in the box. They need to give it inputs, some things to process, and then out the other side comes some result. So you don't really care how it arrives at that result. You just care that I give it these two things, a number, and magically out of the other side, it's added those two numbers together, and I get the result. Now, somebody may come up with some very clever algorithm that uses fewer CPU cycles and saves a bunch of battery, and I don't really care about any of that. All I care about is that out the other side that we get some sort of result. So the things that we're feeding in, we put here. So this is the function name. I called it add two numbers, and notice that I'm using the underscores. And then here we pass it, on the input side, we pass it values. I'm just calling it generically A and B. We could have called it num1, num2, number 1, number 2, whatever. We're choosing these names. Notice that we don't declare the data types. One of the things that's a little bit difficult sometimes with Python is that sometimes we get these functions and it gives us variable names, but we don't necessarily know the data types. But just something to keep in mind that we're sort of assuming that they've given us something that can be added together, so either an int or a float. And then so these are the inputs A and B, and then we take A and B, we add them together, store them in this variable result, and then remember I told you on this box, on the other side of the box, it gives us some value. That's what this return keyword does. Okay, so that's how to define a function is we give it a name. In parentheses, we give it its value. So if the function took in no inputs, which we'll talk about a reason to not take any inputs in, it's empty. If it's one input, we do the variable name. If it's two inputs, we comma separate, and after that, we just keep on comma separating. So that's the basic pattern. And then here we say, okay, result is A plus B, and then this keyword return is what gives us the result on the other side of that box. Now to actually use this, what we do, and as a reminder, anytime we see this colon, that's our code block. So rather than the curly braces, we do the colon, and then we indent one level. Now I'm done with that function, so I'm going to go back over left one outdentation, I guess. I got to look that up. I don't know the actual term. And then what we can do is that we can say, okay, add to numbers 3 and 4. And then so what this is doing now, it's calling this function. Instead of A and B, I'm passing in 3 and 4. It's going to do 3 plus 4 is 7, and then it's going to return the result. How do I get that result? I assign it to a variable. So I might call it total. and then I can print the total. One thing that really tends to throw people off is this idea of what's called scoping. So real quick, any questions on that? That should kind of be familiar from COP2030, correct? Everyone kind of remembers how function works. How many people, be honest, didn't feel super comfortable with functions? That's usually the part of the course where people start to drop off, yeah. So, but does this explanation, does this make a little bit more sense? Now I want you to think, in the real world, you wouldn't create a function this simple. You might create a very complex mathematical function that does something like sine or cosine, or finding the area under a curve, or those sorts of very complex mathematical operations that you just want to be able to call a function. So that's a good example. In practice, most of the time you're spent calling functions that other people made. Okay. And those functions can call functions and call functions and call functions. Now you do write your own fair share of functions. It's just that the bulk of it is because there are so many functions, calling functions, you actually spend a lot of your time actually just calling functions that other people made for you.
Yeah, it's like they build the hardware that you need to build bugs.
Exactly, it's all in layers. Like the very low level functions would be calling like operations on like what are called operating system calls, and then on top of that somebody would do like a print function that actually prints it to the screen, and then you get the benefit of that. We can call that print function and actually print the text to the screen. So now let's very quickly talk about scoping. Notice that I was a little bit careful. Well, let's do one more example. So I can hard code these numbers 3 and 4, or let's do this. I can have x equals 8, y is equal to 9, and then I can go through that same process again. I can say total is equal to add to numbers x and y, and then again print the total. So this should be 17. Perfect. So I can hard code numbers there if I want to, or I can pass in variables. Either one works. Let me briefly talk about scoping, and this is the thing that really throws people off. I was very deliberate on how I chose these variable names because I didn't want to confuse anybody. When I've got a variable defined inside of a function like this, it's scoped to that function. So what does that mean? So let's try this. Now you might think, okay, I can do that, right? Or even better, let's just say result. I should be able to print this, right? Because I've got the variable result, which is equal to a plus b. But when I go to run it, result is not defined. Inside of a function, we have what's called scope. It's scoped to that function. It's only valid within that function. Here I'm outside of that function, because notice I'm indented here, but I'm no longer indented here. So result is only belongs to that function. Why do they do that? Imagine a world where you've got a program that's 1,000,000 lines of code. Imagine a world where you couldn't reuse names. You'd run out of names really quick, especially generic names like I, J, K, result, total, names like that. We would run out really quick. So what we do is make it that those names are only valid within the function. And then any data you want to give to the function, you have to define as an input, and then you send it over to the function. Does that make sense to everyone? We'll talk about scoping in some more detail, but that's definitely one of the areas where I've noticed people get very confused. But we'll just leave this example at that. I think this is a good stopping point. We have about 10 minutes, so if anybody has questions, this will be a time that I can help people individually. Any general questions on anything? So no new assignment this week. Make sure that you've got your other assignments submitted, and the next week we'll have a new assignment based on lists and functions. But that's it. So what I'll do is, if there's since there's no questions,